Hello, we are Team 6 from G4 and this is our web application, Tapao Hero. Here is the general scope of what we'll be walking you through for our project. Let me begin by explaining the problem that we are addressing. So many hawkers in Singapore are badly affected by the current COVID-19 pandemic, and this is due to government restrictions for dining in, implemented ever since the circuit breaker until now. And because of this, hawkers are put in a very vulnerable position, as many of them do not have delivery services to maintain their customer base and businesses. This can either be due to high platform fees charged by delivery services such as Grab or Foodpanda, even the lack of manpower for delivery, or simply just not having the sufficient technological know-how to digitalize their business, as many of these owners are from an older generation. So our solution is Tapao Hero, a web application that helps to promote these hawker businesses in Singapore by encouraging more people to order takeaways from them through a bulk order system. All this without involving any fees or technology for the hawkers to manage themselves. This is done by providing a convenient community-based food delivery system through our platform that allows anyone to either order takeaways through someone else, and this is known as a leacher, or perform deliveries for people who opt for the order option, and this is known as the Tapao. Moving on to our features, we have two main functions, Tapao and Order, for users to choose from, along with supporting features such as sessions, leaderboard, and account overview. For users choosing the Tapao option to help others deliver their food, they will first create a session by entering their postal code, the food that they are buying, and the departure time, which is the cut-off time for orders to be collated by. After being matched with features based on proximity, they will communicate order details through the session chat and end the session once that's done. So for users choosing the order option to order food for themselves, they will search for a session to join by entering the postal code. Similarly, they will be matched to a Tapaoer and they will send all order details through the session chat. And once they have completed the order from the Tapaoer, they will rate the Tapaoer on a scale of 1 to 5. So there will be a leaderboard also to gamify and incentivize the Tapaoers, and they will all be ranked based on successful orders and ratings. Finally, there will also be an account tab for them to track all orders, ratings, and active sessions for their own profile, and this will be based on each unique account created through our login and authentication feature. So now we'll move on to the live demo to give you a better overview. So we will begin with the Tapao flow. So the user can choose to Tapao, means that he will be ordering food for others. So we'll create an account for a new user. So for the Tapaoer, they will have to input their postal code, the food that they are planning to buy, and the time that they will be leaving for the takeaway. This to ensure that the leechers have access to all the necessary details before joining a session. So each Tapaoer is entitled to create as many sessions as he wants at a given time. And this will create a session, as you can see on the left in the sessions page. Now moving on to the leecher flow. For the leecher, we will first also log in. We'll use an existing account for this. So he'll press order and he'll have to input the postal code so that Tapao Hero can match them with the Tapaoer who lives nearby. So as you can see, there's a session that he can join based on the proximity, and he'll be brought to the sessions page to chat with the Tapaoer. So over here, you can see that they can interact and relay all the necessary details needed to deliver the food from the Tapaoer to the leecher. At the top, you can see who is the host and how many leechers have joined the session. So in this case, there's only one, but there's a possibility of having many leechers in one session. So once the food has been delivered, the Tapaoer will proceed to end the session, and the session will be ended. So when he goes to account, and when he refreshes the page, he will see the statistics being updated. So going to the leecher side, the session is ended, so you see the status is now red, and he can proceed to rate the Tapaoer, and these ratings will be calculated as an average for the Tapaoer. So as you can see, both sides will be updated with the correct numbers after this delivery has been made. So we'll now move on to the leaderboard page, and this is where you can see the Tapaoers who have made the highest number of orders. This is to recognize their achievements and encourage more users to engage in this friendly competition to see who has tapaoed the most food. And at the bottom here, you can see where you stand in this leaderboard ranking. This concludes our live demonstration. We will now move on to talk about spelling.
Bootstrap classes like containers, rows, columns, navigation bars, and cards were used throughout our code to style a web page to make our design responsive and seamless. With this foundation made, we applied CSS to customize styles that we intended to create for different features on Tapao Hero. In our primary design process, we used Canva to create a prototype to make it easy for us to reference a design when coding. Our design was planned out carefully with the hearts of the users in mind to make it as intuitive as possible when choosing either path as a Tapawa or Leecher. To go beyond the scope of frameworks taught in WAD2, we also use components from Chakra UI, a component library similar to Bootstrap that helps to speed up the building process and improve responsiveness of elements. We also explored animation libraries using anime.css, which was one of the more user-friendly methods to implement the animation.
So for the logic of our page, we use Vue.js properties such as vModel to retrieve input and send the data to the API call. This is especially crucial when our data changes dynamically. We also have to ensure that the web page reflects the content correctly after retrieving data from the backend based on the role the user is performing. This can be done using vfor, vif, velsif, vshow, and von. Furthermore, we use ME and props to ensure that the pages and components communicate with one another, rendering the pages accordingly. To go beyond what was taught in WAD2, we use Nuxt.js as it provides additional features on top of Vue.js to optimize our airflow. Nuxt.js actually helps us to set up page templates to reduce repeated codes. It acts as a front-end middleware layer to pre-call commonly used APIs before page loads to speed up component display. Lastly, it utilizes additional lifecycle hooks such as fetch to optimize component loading.
Moving on to the backend and data store, our backend is developed using Python Fast API framework and is deployed on Data, which is a web hosting service. So we encapsulate complex user matching logic with one map API integration in our backend. On top of that, Data also provides an integrated database that we use, which is a NoSQL data store. So this is where we store our user and session details, and our backend will directly interact with this data store to update user details and retrieve user details. Next is our secondary NoSQL data store. So we actually host this on Firebase real-time database. So the reason why we have two data stores is because this Firebase real-time database is to provide a low latency storage and real-time streaming of chat messages so that we can enable the chat functionality to work correctly. We chose, if we were to encapsulate this this Firebase real-time database behind a backend service such as our fast Python backend, the latency will be too high. So this will not allow us to stream messages in real time, as we saw in the demo earlier. Yep. So we have secured this real-time database using Firebase Auth. So only authenticated users who log in into our front end are able to read and write messages into this real-time database. Okay. On top of that, we're also using authentication service using Auth0, which is a user access control service provider. So what they do is they provide OAuth2 protocol to secure both our front-end pages and back-end API endpoints. So only authenticated users in the front end are able to call the back-end API endpoints. Because the way this works is the front end, once you log into our front end, you will retrieve a access token that will be then used to attach into authorization header to call our back-end and API endpoints. Okay. So in terms of APIs, what we are using, third-party APIs that we are using, we split into two categories, one for the front end and one for the back end. So the ones that the front end directly calls from is the Auth0 authentication service, which is to register the user, log in the user, and log out the user. We also, the other API that we are using is also Firebase API, which is mainly to stream chat messages in real time, as well as to send chat messages. As for APIs used in backend, it's mainly the one map API APIs. So the first function would be to create postal codes to verify if postal codes are valid. So this is some form of error checking that we do in our backend. Secondly, we also use convert postal code into longitude and latitude with the SVY coordinates format, because in Singapore, this is the coordinates that we use. So this is to ensure that the postal codes are mapped correctly to the longitude and latitude. And this longitude and latitude is then used for this last feature at the bottom, which is for distance measurement. So we want to accurately measure the walking distance between two postal codes via valid routes in Singapore, so valid pavements that people can actually walk on. So it's this to ensure accurate matching between our users so that they don't have to over-exert themselves or over-travel when they are matched incorrectly with people too far away. So moving on to beyond the lab, our group chose to use Git and GitHub to enable development in a collaborative environment. So each of us were able to develop our own features independently from each other, and then later merge it all together quickly and easily. So in terms of conflicts, there was not much conflicts when we were doing the merging together. And I think this component definitely helped us to increase our development speed for this project. So for the second point, we also host our front-end and back-end applications on Heroku and Data respectively. So this enables us, our application to reach a greater number of users, so the public are able to access our application and actually try it out and use it, and hopefully it will benefit them when they try out this application. Yep. So moving on to security features, both of our hosted web services provide SSL encryption. So this ensures that data in transit is encrypted. So this helps to prevent man-in-the-middle attacks. On top of that, our backend is also secured using a OAuth2 protocol, which is provided by the Auth0 user authentication service that we are using. And as for the front end retrieves a short-lived token from Auth0 when users successfully authenticate and log in into our front end. So this actually gives us a full end-to-end secure solution where our front end is secured by Auth0, and then data in transit to our backend is also encrypted using SSL. And when the data finally hits our backend, it's secured by OAuth2 protocol. So only requests with the valid authorization header tokens are able to access our backend APIs. Yeah. So that's all for this presentation. Thank you for listening.